Hello, everyone, and welcome back to another episode of Aquarium Online Academy. My name is Sarah. I'm one of the educators here at the Aquarium of the Pacific in Long Beach, California, and I'm so excited that you're joining me, or I get to join you, because we are going to learn about some really interesting animals today. Now, if you've looked at the title of our program today, it's called No Bones, No Problem. So we're going to be talking about animals who have no bones. Now, as humans, that sounds kind of alarming, right? Can you imagine if our body had no bones? We'd be in a pile on the floor. But there's lots of animals in the ocean and on land who have no bones, and they do just fine. And we're going to explore some of those animals today. Now, before we dive in, I want to set us up so that you can talk to us, share your questions, your observations, just say hi. So I've got a team in our studio today. I've got Connolly and Cole, and they are controlling everything you see behind me. And Connolly just put up our text line. So if you want to ask some questions, if there's an invertebrate you're really want to know something about, if you want to share your observations, you can go ahead and text us at 562-286-1838. And that's if you're watching live, so it's February 13th at 2 p.m. You can go ahead and text us. You can also email us at live@lbaop.org, and anything you send over to Connolly, she can pass on to me, and we can explore together. All right, you ready to get started? So you might notice that there's some things happening behind me. So these are some really special animals, but before we dive into what these animals are, I want to talk about a special word that is going to describe the animals we're talking about. So I mentioned that they have no bones, but I'm going to have Connolly put up our special vocab word for today. Excellent. So this word right here. Have you seen this word before? Go ahead and give a thumbs up to the camera if you know this word. A thumbs down if you're like, I don't think I know that word. Or a thumb in the middle if you're like, maybe I know it, but I'm not really sure. Go ahead. Now, I'll say it out loud, and maybe that'll jog your memory a little bit. This word is an invertebrate. So the animals we're going to talk about today are invertebrates. Have you heard that word before? Maybe you've heard part of it. Have you heard of a vertebrae or a vertebrate? So if you go ahead and reach behind you, and you feel along your back, you have your spine. And if you feel kind of up and down your spine, you've got all of those bumps, and those are your vertebrae, and they're stacked together, and that is your backbone. So an animal that is an invertebrate has no backbone, and really no bones at all in its body, which again kind of sounds wild, but there's so many animals that have no bones in their body. Now for us humans, our bones help us do a lot of things, right? I mentioned you'd kind of be in a pile on the floor if you had no bones. So they help us stand up tall and straight. They help us walk and run and do all these things. And I'm talking with my hands, and my bones help me do that. So these invertebrates, they have to find other ways to survive and do the things that we do with our skeleton without one. So we're going to explore some different invertebrates today and see what adaptations, what things on their body that help them survive, that they have, what makes them special from animals or different from animals who have bones. So again, I'm going to step off, and I'm going to have Connolly take away that word invertebrate. Perfect. And we're going to make some observations of our first invertebrate animal. Do you know what this animal is? Have you seen them before? That's right, these are jellyfish or sea jellies. Now these are a specific kind of sea jelly. These are called sea nettles. And we have them here at the aquarium. This is one of our webcams. So maybe you've watched a program with us before, and we always talk about our webcams. But I think our webcams are fantastic. They're a great teaching tool for us, and they're also really fun just to watch at home. So we have cameras inside our exhibits, and you can check in on our animals whenever you want. Now I wouldn't recommend checking in on them late at night, because the lights are off and it might be hard to see them. But any other time of the day, you can check in on our animals. So let's make some observations. Let's share what we notice about these invertebrates. We'll put up that text line again. You can think your observations. You can text us. You can share with someone you're watching with. Maybe you're watching with a friend or an adult. Maybe you are watching in a class. You can share, what do you notice about our jellies? Wonderful, and I see that we've got some questions coming in already. So the question is a snake an invertebrate? And that is an excellent question. So a snake is actually not an invertebrate. I know it's kind of hard to picture. Their bodies are really long and skinny and kind of slinky when they move. They're really flexible, which might make us think that the way they move is maybe kind of similar to how these jellies are moving. But if we were to take an X-ray and look inside a snake's body, they actually have a backbone. They have a spine. So snakes are a reptile, but they are not an invertebrate. That is an excellent question. Wonderful. Did anyone make observations of our jellies? So I notice the way that they're moving. They're kind of moving all around. and they're moving that yellow part of their body, kind of opening and closing it. So this part of their body, right here, we call their bell, and they open and close their bell. Now, that helps them a little bit with movement, but jellies are actually a special kind of animal called plankton. Have you heard that term before? It's a pretty common term when we talk about things in the ocean. Oftentimes we think of plankton being really tiny animals, but plankton really means an animal that drifts or wanders, and it can't swim against the current. So jellies, even though they can move, they can't swim against where the water pushes them. So they just kind of drift all around. And having no bones makes their body a lot lighter and allows them to drift easier. Now let's take a look at a picture of a jelly. It can be a sea nettle or any of our other jellies. And let's talk about the different parts of their body. Excellent. So this is another Pacific nettle, even though the coloring looks a little bit different. But we notice, so we've got the bell, that's the top part. And if you kind of see, where do you think there would be bones, right? There's not really any place for them to have bones. So our jelly is an invertebrate. They've got their bell, the top part here, and then they've got these red strings here and these white kind of fluffy parts. So those are two really important parts of our jelly's body. Now, those of you watching, you might be thinking what a jelly does to protect itself, right? So animals who have no bones, they don't have anything hard on their body, or oftentimes they don't have anything hard on their body, so they have to find other ways of protecting themselves. And jellies, they can sting. That's right, jellies can sting. So these red strings you see here, these tentacles, these are where a jelly will sting. So they have stinging cells in those tentacles, and if any animal bumps into them or drifts through them, they can sting that animal. Now these white ribbony things, maybe you thought those were the stingers, but those are something called the oral arms. And that is how they bring food up into, well, they don't really have a mouth, but up into their body to digest their food. So think about it. An animal might try and swim through the jelly. They get stung. They're not alive anymore. They get stuck on these oral arms, and then they can travel all the way up into the stomach of our jelly. And that's how they're able to eat their food. So these animals have found other ways to do the things that we do, but they do them without bones, and they're pretty fascinating. So those are our jellies. So that's just one invertebrate. Invertebrates are a huge, huge group, and we're just going to cover a couple of them today. So let's take a look at the next invertebrate we're going to explore. Excellent. So there's a bunch of invertebrates in this pool here. Now this is a video, so this is not a webcam like the one we were watching before. This is a video of one of our exhibits here at the aquarium called Coastal Corner, and it's designed to look like a tide pool habitat. Now habitat meaning a home for animals, and a tide pool is a rocky area. Oftentimes we find them close along the shore. We have lots of tide pools here in Southern California. And there's lots of animals who live in tide pools, and most of them, I won't say all because there's a couple who aren't, but most of them are going to be invertebrates. So all the animals you see here, these are invertebrates. Now maybe upon looking you're like, are they all animals? Well, there are some rocks and sand here, but we have lots of different invertebrates living in this tide pool, and we're going to talk about a few of them. Now the first one we're going to start with are our sea stars. Oop, that's not a sea star. This sea star right here. There's a sea star here, and there's another kind of sea star here, right there, and then right here as well, and here. So many sea stars. So sea stars are an invertebrate. Wonder if we can bring up a picture of any kind of sea star. Perfect. So these ones specifically are called bat stars. Now, sea stars are an interesting invertebrate because before, when I was talking about the jellies, I said that invertebrates, they have nothing hard on their body. And then I corrected myself, and I said, most invertebrates don't have a hard thing on their body. But there are some invertebrates whose bodies are hard or who might have something hard on their body to act as protection, but it's not bone. So if you've ever touched a sea star, which if you visit us here at the aquarium, if you go to the tide pools, you can gently touch them in the tide pools. Sea stars, they feel really hard. They actually feel like rocks, but that doesn't mean they have bones. So they have these plates that make up their body, but it's not bone, so they're still an invertebrate. But they do have a hard body. Now these are really interesting animals, sea stars, because even though they might feel like a rock, and sometimes they don't look like they do much, they kind of look or act like a rock, they're really fascinating animals. Just like those jellies had some really interesting adaptations, sea stars do as well. So I wonder if we can take a look at the underside of a sea star. This is the top part. Excellent. So this is the underside of a sea star. What do you notice? You see those little polka dots? So they do have little polka dots, but those are actually the sea star's feet. Is that what you thought I was going to say? Maybe you knew that already, but these are the sea star's feet all along here. So each arm, let's count how many arms this sea star has. Ready? We've got 1, 2, 3, 4, and 5. 5 arms. And all along their 5 arms, they have those little polka dots, which are actually suction cups. I think they kind of look like macaroni noodles when you see them in person. But those suction cups are their feet. We call them tube feet. Not 2 feet, because they definitely have more than 2, but tube feet. And that's what they use for a couple things. They use them to hold on. As you can see, this sea star is holding on to the glass of the exhibit. So it's not flat on a rock, it's actually on its side holding up, and you can see all of its tube feet. So they use them to hold on, which is important in a tide pool habitat. So one of the things about tide pools, they're really cool for us to see because it's easy for us to access these animals. But for those animals, it can be a really challenging habitat because there's lots of waves action. So the waves are crashing over those rocks all day long, and the animals have to withstand those waves. So sea stars use those suction cups to hold on so they don't get tossed out into the open ocean. So those tube feet, their suction cups, help them hold on. They also help them move, right? We think of feet help us move. So sea stars, their tube feet help them move. They also are used for something else. And this one might surprise you. They also use their tube feet to smell. You heard that right. They smell with their feet. Now, we don't smell with our feet. You might have stinky feet out there, who knows? But they don't have smelly feet, they smell with their feet. So whenever a sea star is crawling along, they're actually smelling for their food. What do you think they like to eat? Any ideas out there what a sea star's favorite food might be? I'm going to grab it and I'm going to put it on my document camera. Their favorite food, it's going to be a slow-moving animal, I'll tell you that. Because sea stars, even though they have all those feet and they move around with them, they are pretty slow-moving. And so they have to find an animal that's as slow or slower than they are. Any guesses? All right, we're giving my document camera a minute to warm up. So the animal that they like to eat does live in the tide pool, just like they do. And this animal has 2 shells. Interesting. Shells. So animals with shells often are other invertebrates, but they do have a hard part on their body, and that protects their body. All right, we're almost there. My document camera is still warming up. All right, here we go. Oop, that's too close. Excellent. Does that look familiar to anyone? These are mussels. So these are the shells of mussels. There will be 2 shells. These ones don't go together, so it's not from the same mussel. But they would go together like this. And inside is a squishy animal that sea star likes to eat. So sea stars like to eat things with shells like this. Let's go back to our sea star. How do you think the sea star eats? Either one. Look at their body. They don't really have hands like us, but they are going to use their suction cups to help them eat their food. So what the sea star is going to do is first they're going to use those feet to smell for their food. And then when they get to the clam or the mussel, they're going to use those sticky feet. They're going to stick them all over the shell, and they're actually going to pull that shell open. And then once they have the shell open just a little bit, they're ready to eat it. But they eat it in a really different way than we eat. Think about today when you had lunch or breakfast or snack. You put the food in your mouth, you toot it up, you swallow it, and it goes to your stomach. Absolutely. Sea stars, they kind of do the opposite. So they start with their stomach, and they actually pull their stomach out of their body. They put it into that shell. Now, their stomach has acid in it, which breaks down their food. And as humans, our stomach has acid in it, breaks down our food too. So that acid breaks down the food, and then they slurp their stomach back into their body. Isn't that wild? So right here in the middle is where their stomach is. So you can't really see it because it's stuffed inside their body right now. But they actually pull it out. It kind of looks like balloons. Not like a huge, huge balloon, but it kind of looks like a little balloon. And they'll stuff that into their food. They'll digest it, break it down, and then pull it back into their body. Pretty fascinating for an animal that just looked like a rock. Excellent. Thank you, Connolly. So this is a picture of another kind of sea star. But what we're looking at is its stomach. So we can see its suction cup feet, its tube feet. It's on the glass of an exhibit. But this stuff in the middle, that is its stomach digesting some food. Pretty interesting, huh? Now there's one more fascinating thing about there's more fascinating things about sea stars. But one more fascinating thing I want to talk about, and that has to do with their arms. Anyone out there know what they can do with their arms? What's really neat is they can move them in all directions. Each arm can move independent. They have water moving through their body, and so they can be really flexible. But even cooler is if they lose an arm, they can regrow an arm. We've got a big word for that. We call it regeneration. But that just means to regrow their arm. Now you might wonder, how would their arm fall off? So maybe this sea star is hanging out in a tide pool, and another animal maybe tries to eat its arm. Or the waves push a rock, and maybe a rock falls on their arm, and they break their arm. They can grow a brand new arm, which is pretty wild, because can humans do that when we have bones? No. Now, our bones can grow back together if we break them, but we can't regrow an entire new bone if we don't have it, like a sea star can grow a new arm. I think that makes invertebrates pretty amazing animals. All right, let's take a look at another animal from that tide pool. So let's go back to our tide pool. Excellent. And let's take a look at another animal. Now, in the ocean, there is a high volume of invertebrates we find in the tide pool, and they tend to be smaller animals. In general, invertebrates tend to be smaller, but it's definitely not an absolute, because there are some really large animals that are invertebrates as well. So things like giant squid, which are huge animals, they are invertebrates as well. But we're going to focus mainly on our tide pool animals today. So the next one I want to talk about is really different looking than our sea star. I want to talk about our anemones. Now, if you're looking at this image, can you point out an anemone? Or maybe describe a color of an animal you think is an anemone? There's a lot of different animals in here. I wonder if we can spot which ones are anemones. Now, one of my favorite invertebrates is this one right here, which is a sea cucumber. It's not an anemone. The sea cucumber is related to the sea star. And there's another animal all the way over here. Did you notice this purple one that's got spikes? That's a sea urchin. And that's also related to the sea star. And like the sea star, it's got a hard exterior to its body. But I want to talk about this animal right here. There's one right here. Maybe you spotted this big one right here. Or this one is also an anemone. It's just kind of curled in on itself. Or even this one right here and right here. These are sea anemones. Let's take a closer look at a sea anemone. Excellent. Now this is called a fish-eating anemone. You want to take a guess at what it eats? Fish. Excellent. Very good. I was going to say something else, but you're right. They eat fish. That's how they get their name, fish-eating anemone. But this is a sea anemone. So what do you notice about this animal? What observations can we make? Do you notice any colors on its body? I kind of see three main colors, and it's kind of broken down into different sections, right? So down here, this kind of maroon or like dark red area, this is part of the anemone. And then they've got these white noodly-like things. These are their tentacles. And then they've got some yellow here that kind of looks almost like a sunflower. So our anemone has this sort of stalk to its body. It's sort of like a long tube, and that's where all their organs and insides are going to be. And then we see this yellow part here, and in the middle, this is their mouth. So these animals, they do have to eat, right? Even though these animals don't have bones, they still need to eat. That's one thing they need to do to survive. And so here's the mouth of our anemone. And then these white things, their tentacles, are all around. Now, does anyone know what their tentacles are used for? Now, I'll give you a hint. The anemone is a relative of our jelly. So sea jellies, like the nettle we looked at the very beginning of our program, and our anemones, they are related, and they share something in common. Do you remember what that jelly did to protect itself? That's right, it stung. It could sting things to protect itself and also to catch its food. Well, anemones, they do the same thing. So their tentacles here all have those same kinds of stinging cells that the jellies have, and that's how they can protect themselves and catch their food. Sometimes people will call anemones plant-like animals because they kind of look like a plant, and other animals in the ocean, they agree, and they think it's just a plant and they might swim through. But what do you think happens if an animal swims through all these tentacles? They might get stung. And then the anemone can either eat it if it decides it's food, or just get rid of it if it doesn't want to eat it. So what do you think an anemone likes to eat? Do you think they're really picky eaters? I'll give you a hint. The anemone, it kind of sticks onto a rock, and they don't move very much. So they're not searching for their food. So if they're not moving a lot, it makes it hard for them to be picky. So they're pretty much going to eat whatever comes to them. And a lot of times it's things like small fish or shrimp. But I'll tell you, I've even seen a sea star in an anemone's mouth. Now that anemone, like I said, didn't go after the sea star. It's likely the sea star fell into the anemone, and the anemone thought, all right, I'll see if I can eat this if there's anything good in it, and started to eat it. So pretty much whatever gets caught in their tentacles, they're likely to try to eat. Here at the aquarium, we feed them shrimp and fish, which is pretty much their main diet. So they'll grab the food from their tentacles here, and then they'll bring it into the center, and they'll digest it. And if we go back to Coastal Corner, this is what they look like when they're eating. They pull all their tentacles in and kind of cover them up because they don't need to catch any more food, and that's what they'll do when they're digesting their food. Sometimes if you go to the tide pools, you'll also see anemones like this covered up when they're out of the water. So they can actually hold water in their body and curl themselves up, and that way, while they're out of the water, as the tide is changing, they stay wet and they don't have to worry about drying out, and then they'll open up again when they're in the water. Excellent. All right, we've got a little bit more time. Let's take a look at another invertebrate. We're going to stay on the tide pool for a moment. Excellent. So we got another question, and the question is, are axolotls invertebrates? So I want you to take a moment and think about what we've talked about so far, and what do you think? What do you think? Do you think axolotls are invertebrates? Now, unfortunately, I don't think we have any great pictures of axolotls. We might. I'm going to send Connolly on a little bit of a search, see if we can find a picture of an axolotl. We weren't prepared for this question, but we love it. So just give us a minute. All right, we did find, oh my gosh, such a cute picture of an axolotl. I'm glad you asked this question so we could look at this picture. Look at it. This to me is like a glamour shot, like it's posing for its picture. So this is an axolotl. They are a kind of salamander, which are animals who have bones. So even though, again, their body is kind of flexible and pretty wiggly, which might make you think that they are an invertebrate, they are actually a vertebrate animal, and they do have a skeleton. Great question. Keep them coming. One last look at our cute little axolotl. We do have axolotls on exhibit here at the aquarium. So if you're looking to see them, come visit us. We've got a couple on exhibit. But let's go back to our tide pool. There's one more animal in our tide pool in here that I want to talk about, and then one more animal I think we'll get to just before we have to say goodbye. But I want to look at this animal right here. And we can even stay here unless we have another picture of this animal. Does anyone know what this is? It's another rock-looking animal, right? Kind of looks like a rock. But I kind of mentioned them before. That is a sea snail. Now, you might have snails that live in your garden, at home, or at school, or at a park nearby in your community. There are snails on land. Excellent. And then there are snails in the ocean that we call sea snails. Now, this is one of my favorite sea snails. And yes, I do have favorite sea snails because they're pretty cool animals. They're also really cute sometimes. This is called a chestnut cowrie, and it has a hard shell. So again, I mentioned that invertebrates, even though they have no bones, and many of them have really soft bodies, and many of them don't have anything hard on their body, there are some invertebrates who have things like shells that protect that soft body. So this polka dotted part here, you see, and then you can even see their little feelers right here, this little orange thing that's part of their body. They have a squishy body that has nothing hard on it or in it inside the shell. But think about a really squishy body. It might be easy for something to squish it or for an animal to eat it. And so snails have their hard shell that they carry around everywhere with them, protecting their body, and that keeps them nice and safe. So I just wanted to talk about our snails for just a moment, but we have saved one more animal. Now this is, I've said they're all fascinating, and they are all fascinating, but this last animal is very fascinating as well. Our last invertebrate we're going to talk about is the octopus. Excellent. Did you all think it was going to be an octopus? Maybe you knew that already, that an octopus was an invertebrate. Now this is one of the ones that it is small, but there are larger octopus as well. Just like octopus and squid, their relatives, and they can get pretty large, but many of them are small. So this one right here is called a two-spot octopus. Want to guess why we call it a two-spot octopus? See this blue spot right here? It has two of them. There's one on this side, and the other is on the other side, so we can't see it, but that's how it gets its name as a two-spot octopus. And this two-spot octopus, they don't get very big, maybe about this big. They're local to us here in Southern California, and sometimes you might find little ones living in the tide pools. So they might live amongst those sea stars and the sea anemones and the urchins and the snails and the sea cucumber. But the octopus is an interesting animal because the adaptations, the things they have on their body or that their body can do to protect themselves are different from so many other animals. So one thing they can do to protect themselves is they can change their color. Now I'm going to have Connolly bring up a picture of another octopus, and we'll take a look at how different that one looks. All right, can you find the octopus in here? Are you sure there's an octopus in this picture? I'm just kidding. There is an octopus, and maybe it's easy for you to see, but I'm going to tell you a secret that this octopus here is the same one as in the other picture. It's the two-spot octopus. It's the same octopus. Look, it's got its spot right here. But the two-spot octopus can change its color to match its surroundings. So that grayish color is pretty much like their base color. Most of the times you see a two-spot, that is their normal or natural color. But if they need to, they can change color to blend in. So they can camouflage. Now maybe you've heard that word camouflage before. It means to blend into their surroundings. But that is a really important adaptation that animals use to protect themselves, especially invertebrates, right? They don't have anything hard on their body. They're really soft and squishy, like an octopus. They have to find other ways to protect themselves, and so blending in completely to their surroundings is a really great tool for this animal to use. Let's go back and look at the other one really quick. Excellent. All right, so here's our two-spot. Now, another thing to take a look at is not just the color, but look at the texture of its body. Like, look at how smooth the octopus looks, especially up here. This part is where its organs are. So its head is pretty much in the middle. It's got its arms here. And then this is where all of its organs are. So now let's look at that yellowish one, the same octopus, but just different color. What do you notice? Is it changed at all? Look at these little bumps on it. Right here. So the octopus can not only change the color of its body, it can also change the texture. So the feel or the how it sort of looks on its body. And that way it can match its surroundings. So if it's on a bumpy rock, or if it's near coral, or in the sand, it can change the texture of its body to match its surroundings. So it is what we call the master of disguise. It blends in super well. And it blends in, one, to protect itself, but another reason an animal might blend in is to sneak up on the thing it wants to eat. And that's really what the octopus will do, is they'll lie waiting. They'll blend in so no one can see them, and they'll wait for their food to walk by. And I say walk because one of their favorite foods are crabs, who are going to walk by, and then they can sneak up on their food because that animal didn't see it coming. Now, the octopus, talking about sneaking up, how do they move? They have suction cups. They have tube feet, just like the sea star did. See if we can get a look at their suction cups. Excellent. So here they are all bunched together. I wonder if we have a zoomed out view where you can see them. Excellent. So this is our giant Pacific octopus. So this is one of those larger invertebrates. But you can see all their suction cups. And they work very similarly to the way that the sea stars do. They help them move. They help them hold on to things. And they can also help them smell for their food. And as I mentioned, their favorite food are those crabs. Excellent. All right, everyone. We are about out of time. Like I mentioned, there are thousands and thousands of invertebrates, both in the ocean and on land. So if we covered all of them, we would be here for days and days and days. But we have one more question before we go. What is that question? Ooh, excellent. So the question was, how do axolotls regenerate part of their body if they're not invertebrates? So if you didn't know, axolotls can regenerate different parts of their body. So being able to regenerate, while it's not a common trait, so we don't often see in a lot of animals, it's not specific to just invertebrates. So they're able to grow parts of their body. Even though they have bones, they're able to regenerate parts. Now, how they're able to or why they're able to, that is beyond my knowledge. And I hope you scientists out there who are asking all these questions continue learning, continue asking questions, maybe even come visit us at the aquarium, and we've got some axolotl experts you could talk to, and they could definitely give you more information. I'm going to get off camera and I'm going to go look that up so that next time you have your question, we'll be able to provide you with a better answer. And that's what I think is amazing about you joining us and us doing these programs is we get to teach, but we also get to learn at the same time. So I hope you had a good time learning about some different invertebrates and asking us questions. We love your questions. We love that you're joining us. If you are watching with a class today, teachers, if you could send us in the numbers, that's super helpful for us to track who is watching and our community, and that way we can better serve you and give different programs that better suit your needs. All right, everyone, thank you so much for joining us. If you're looking for more programming, we do have another program coming up at 3 o'clock. It's going to be a draw with us. So we're going to draw something special, and you can draw right along with us. Hope to see you then. Bye, everyone.